Okay, so another sun video. I've been waiting for sunny skies near the equinox. Finally got it. And also sunspots at the same time, which is a big deal because you can't track sun motion without it except for its path across the sky. And so you can see here, just as a reminder, that right now during the equinox, we're supposedly at this one. You know, we're a little bit past it, but it's not a significant number of days. And excuse me, I've been tracking the sun since this June solstice, which would be over here on the right side where the Earth is kind of tilted in the northern hemisphere, according to the current model, toward the sun. And at the equinoxes, excuse me again, there's no tilt toward or away from the sun. It's just kind of to the side. So whether that's significant or not, according to what I've been able to find, supposedly it means we're looking more straight on to the sun. I'm not sure about that, but that's what they tell me. And so, of course, when I start to do a hangout, I get a frog in my throat, but stupid frogs. Anyway, you get the idea that supposedly there should be a difference in the motion we see in the sun this time of year compared to one of the solstices. Okay, so let me go. I think the next picture will come up. Yeah, this one that I made before in an earlier video where it shows on the upper left there that the sun, being supposedly in a gaseous state, has fluid dynamics going on, which means the center spins faster than any of these latitudes. And they will say that it takes about 25 days at the equator for any spot to move from one side to the other from our view. And it takes longer as you get toward the pole. Okay, so right now we should be looking fairly straight on at the equator. Okay, and down here you can see the calculations that what 25 days at the equator amounts to is that it'll take about, a spot would move supposedly laterally, meaning across the face of it, about 14.5 degrees per day, which is about 1/10 of the width of the whole sun. So about 1/20th or about 1/5 of half the sun. I've never seen a group of spots move more than halfway across the sun. So I should be able to detect that movement from one day to the next is what I'm getting at. And so if we're seeing a movement of 180 degrees, like things are going around this way like a half a clock face, then if they're also moving this way, I should be able to detect that from one day to the next, at least a little bit of movement toward, from an edge to the center and back to the edge again. I've never seen that. But here we are. I've only been really closely watching it since the solstice, and so now we're at the equinox, and I should see some kind of difference. I should see the spots move noticeably across the face of the sun. Okay? But this is what I got yesterday. And you can see the times. There's 2 instances where I skipped an hour for some reason. I don't remember if I was busy or if I just forgot. But this is the group of spots we got right now. And this is how they're moving. What I'm not seeing is a significant move across the face on any given day. This is one day. Like I said, I had to wait for weather and spots to appear. And this is what it's doing. It does clearly appear to be a sphere. The spots near the edge appear to be squished. And I also notice that it's still doing what I observed, which is that the speed of the spin is faster at solar noon than it is at any other time of day. It's slower in the morning, slower in the evening, and moves a lot more during the middle hours of the day when the sun is at its highest, which right now at my latitude is around just a few minutes before 1:30 local time is solar noon. And I can verify this every day. I'm not relying solely on timeanddate.com. I'm checking it against my sundial. It took me a while to find that word for some reason. Sundial set to our location. And So yeah, it doesn't mean that just because the sun appears to be spherical and the moon appears to be spherical that everything must be spherical. Even in nature, crystals are not spherical. So nature is not exclusively spherical, and it takes a lot of presuppositions to arrive at conclusions. Everything is basically circular reasoning in theoretical physics. And of course, astronomy is almost completely theoretical. They watch stuff like I'm watching stuff here, but every idea about how to interpret the data is where the sticking point is, just as it is with age of the Earth. Everybody has the same material objects to look at, but they reach very different conclusions based upon their presuppositions. And so this is how the sun's been moving. And this, just by the way, is, before I move on, an improvement of a drawing I made on a previous hangout where I talked about the double concave lens and how that affects how we see the sun. It's moving basically, if this is true, a true model representing the distortion that we see of things in the sky as they move, then from my camera angle, I'm looking this way through a lens shaped like that. Okay, this is a more 3D look at the one on the left. I had a drawing before, but it wasn't as good. And so we're looking at this angle through a lens that is shaped like a double concave. And as it moves, where's the least distortion? Right in the center. Especially if you were at the equator, you would have zero distortion for the most part, because you would be looking straight up through the skinniest part of the lensing at something directly overhead. There you would have no distortion. Every place else you have distortion, especially as you get toward these edges, which are the northern latitudes, southern latitudes. This is the equator, and going all the way back, that's the equator. The sun would be moving straight across with minimal to no distortion. But at any latitude beyond, say, the tropics especially, is going to be distorted. You're looking through a lens at an angle. And it's moving so that you also, no matter where you are, will at solar noon, you will have the least amount of distortion, but you will still have significant distortion at a latitude significantly outside of the tropics, which is tropics meaning where the sun can possibly ever be 90 degrees overhead, which is minimal distortion. But so as the sun moves through the day, you're going to get varying amounts of distortion. And the fact that we have the least of it at solar noon is also significant, and maybe correlation is not causation, but I've noticed that when we have the least distortion is when we have the fastest spin of the sunspots, spin being clockwise motion. So take that for what it's worth, but now let me stop sharing that one and go to a slower look, a more detailed look at, if I can find it here, the motion of those sunspots. So here we have, I put a little grid of 15-degree angles all over the sun and some concentric circles so we can track the sunspot motion better. You can see, hopefully you can see my cursor running around here. I don't know if you can or not, but yeah, okay. I had to check the watch page. We can see we've got a big spot, little spot down here, and we have another spot here and a big spot, little spot here. I don't know if you can see the little one, but I don't know if I can blow that up at all. Well, I can, but I don't think it'll make it more visible. Anyway, we have these three spots to begin with, okay? This is, again, on a given day. And we're going to watch them move. That's a 2-hour jump. That's one of the 2 places during the day I missed an hour. So that's a 2-hour jump, okay? It's about not quite one grid, I guess. And notice that the spots don't all move at the same speed. They move in relation to each other, but since the ones on the outer edge are away from the axis of rotation, they're going to move faster. In other words, they have more distance to cover. See, as you go in here toward the center, a grid gets narrower and narrower. So if they go a grid here and a grid here, it's not the same amount of distance. So there's the first to the second, and then that, like I said, was a 2-hour jump. So in the morning, it's moving very slowly. Okay, here's an hour jump from 10:30, 11:30 thereabouts. You can see the time up here. So from 10:30 to 11:30, we move this far. Then from 11:30 to 12:30, we really jumped. Okay, we're getting toward the middle of the day here. And look at all the spots where they're going. Once again, the one toward the center is not moving as much. Okay, then we go from 12:30 to 1:30. Look at that jump. Pretty big even for the innermost spot. Then we're going to go a 2-hour jump. Pretty significant, but 2 hours, so take that for what it's worth. And then we're going to go another hour to 4:30. The innermost dot is not moving much. Outer ones are moving almost a whole grid. And then the next hour, very little movement, because we're getting toward the end of the day, very little movement. And the next hour, less movement. And look at the inner dot. It moved out a little bit, away from the center, which is interesting. Because, if anything, if you look at the top left group of dots, they seem to move in toward the center ever so slightly. Now, what I did was track from beginning to end those 3 dots. I used the path tool, and I just clicked on each dot as a point, and that's what I got. That's how they're moving through the course of one day. And obvious clock motion, obviously faster at the rim than the center, but there's really not any lateral movement to speak of. There's a tiny amount at the end of the day where it seemed to move toward the right a bit, but not all the dots moved in the same manner exactly. But it's hard to tell when there's such a small amount of movement. Now, here's what I got this morning. I wanted to check the same time from one day to the next. Okay, so that's the next test. Within a day, it's been very consistent. Doesn't matter what the season is, whether it's a solstice or an equinox. But what about from one day to the next? So let me hide these other layers and go back to between today at it's 8:18. You can see 8:37 the other day. So very close to 24 hours. Let me get rid of those. Not the grid. I want to get rid of the paths. There we go. Okay, here's yesterday. Here's today. What did they do? They're starting in roughly the same clock positions, but they moved laterally. That's why I say the spot thickens, the plot thickens. They moved laterally, but of course not going left to right, but going across nonetheless. They're going this way. Okay? So let me look at that again. They start there. They move about one grid. And remember that the inner dot has, if it's moving the same amount of space, but is it? So what I did, I made these 3 arrows. I made the first arrow tracking exactly the first dot. See, it goes from the beginning of the arrow to the end of the arrow. I took that same arrow, same length, and duplicated it and moved it to the other dots, not moving the same distance. See, the other dots don't move as far. Okay? Now, someone will say that's because the sun spins faster at the equator, but what exactly part of the sun are we looking at? According to any stretch, any boundary, any extreme guesses as to how the speed of the sun's surface spins at different rates at different parts of the sun, going from pole to pole. We are never looking down at the sun's pole, okay? But we would have to be if this is true, if the standard model is true for the clock motion. So how is it possible to have both clock motion as if we're looking at the sun's pole and lateral motion as if we're looking straight on at the sun's equator, even if it's, you know, at an angle like this? They can't both be true in this current model. That's what I'm saying. You know, they move like this at different rates, and the reason it is not because I'm not taking into account the grids or the concentric circles. What I'm doing is, like I said, those 3 yellow arrows are based upon duplications of the first one, which is the inner dot at the top here. Okay? That arrow is the same length everywhere. So the inner dot speed is not the same as the other dots. The other ones aren't moving as fast. But they're all at the angle. Look at the angle of movement. They're all going in the same direction pretty much. Those arrows don't have to rotate. So that direction should be how the sun is spinning according to the standard model, yet all the dots are not moving at the same speed in spite of the fact that they're all relatively close to each other as near the sun's equator line. If the equator is this direction based on the arrows, say it's this line, it's pretty close to that angle of those arrows. That's the sun's equator, according to what I'm seeing. Therefore, these dots should move pretty much at the same speed. But they're not. And they're doing this at the same time that we have this motion. How can both those things be true? Well, someone would say, well, the clock motion is on one day, and the lateral motion is 24 hours. But here again, not only have I shown in previous videos that the clock motion is backwards, it should be moving counterclockwise because my camera is allegedly moving clockwise. Whether you look at the top arc of the camera or the bottom arc of the camera, they're both going clockwise. Therefore, the spots must go counterclockwise, but they're not. So camera spin is not causing this rotation that we're seeing. And if instead it's being caused by looking at the sun's pole, then we can't also see this lateral movement from one day to the next. It doesn't make sense. It can't make sense in the standard model. So I don't care how my camera is fooling people, allegedly, into thinking there's a clock rotation. The fact is that I'm seeing 2 different kinds of motion. And one is equatorial, face on, like you would expect at the equinox, and the other is this clock motion that is not being caused by my camera. So take that for what it's worth. I don't know what to tell you that means in any model. Yeah, it's dirt on my lens, dirt in my eyeballs. I do have floaters, but this is the camera, so the camera can't see my floaters, as far as I know. Oh, it's a reflection of the floaters. Yeah, well, then they should be going every which way, and there should be a gazillion of them. There's always an ad hoc explanation in there. But this is the plot thickening. This is what is being observed, and trying to find some way to explain it in any model, because I really haven't even looked at other cosmological models such as flat Earth in any of this stuff, because you first have to tell people why their current cosmology is wrong, and then you have to have something ready to fill in the vacuum when they drop it. It's like going on a diet. You can't just take certain foods out of your diet. You have to replace them with something else. And this is just a psychological issue that people need. And I think it's a good strategy. And as far as defects in the dome, I mean, it's possible, but they come and go. And one thing I've been curious about, since I can't watch the sun 24 hours, is when exactly a spot disappears. I have seen them go off the rim. I mean, I've tracked them from one day to the next, over the course of a week. It may take a spot to go over the edge, which is close to their 25 days at the equator thing. But I think that they are taking the observations and making the 25 days very arbitrary based on that. They're not, I mean, how else do you track the sun's motion but by sunspots? So those videos, pictures, slideshows of the sun as allegedly this cauldron of stripe, like fire strings, I guess, for a better lack of description, is CGI. And if it's not, it's certainly highly processed. And I've never seen anything like it with my solar filter. And allegedly you need different kinds of filters to see such things. But I don't think I'm aware, and maybe somebody can find some amateur footage that isn't suspect of that fireball looking sun that they can track its motion without relying on sunspots. Anyway, going on the tools I have to work with, this is what I'm seeing. I'm seeing two different kinds of motion, a daily rotation and a perhaps you could call it a weekly rotation along the equator. But the problem is also I would have great difficulty tracking the sun at the opposite, the winter solstice, to see what a given spot does. But the thing is, spots are fairly short-lived. It's hard to track them over a long period of time to see what they do in a complete life cycle of a sunspot. Not only can't I see it when it's night here, I can't track it through all the seasons. I mean, as spots don't last that long. So we really are limping along here with limited tools, but at least I can say this is what I observe. Again, the arrows, if you came in late, are the tracking of spots over the course of a day, yesterday. And then the yellow arrows are tracking of those same groups of spots from one morning to the next, at about 24 hours apart. And here again, what you would have to do is to see a group of spots, whether they ever move laterally from one day to the next in the same manner at a solstice as they do at an equinox, because that would again put a serious damper on the current model, since you're tracking from day to day rather than one day, and put another nail in the coffin as far as I'm concerned. Yeah, that's the thing, is we don't see an axial rotation there. Like I said, not even in the standard model are we looking ever at any point in the seasons on a pole of the sun, north or south, that we would see the clock motion. That's the only way you would see clock motion, is if you were looking down at the sun's pole or up at it, whichever one. And so that's why people try to write off the clock motion as camera tricks. And I did the camera trick video to put that to rest, because even if the camera is artificially inducing the clock motion, it's making it backwards. The clock runs backwards the way it should. So anyway, according to standard theory, the sun does spin on its axis the way the Earth does, and everything else does, except there are some things that spin the opposite way and they can't figure it out. And the poles of everything, as far as I know, in our solar system, if so-called, is roughly pointing in the same direction, although the sun's pole is not at Polaris. It's something fairly nearby as far as we, going by stars as they appear to us in the sky. So we should never, ever in any model be looking at the sun's pole, north or south, and watching it spin. And we know it's not camera tricks, so that's a real sun motion, and from one day to the next, the sun can also wobble. The interesting thing will be is if I get If those spots are still there tomorrow morning, and if we still have good sunshine, then I will be able to track 3 mornings and see if those spots have continued to move in the direction of those yellow arrows or not. Because what I suspect will be the case, as it is with the moon, which is easier to track since it has regular features, is that it wobbles in different axes. That is to say, it not only rolls like a clock, but it also tilts forward and away from us, and it rolls side to side a little bit. So we got 3 different kinds of motion, or 4, as I showed in the one video, where we have X, Y, and Z axes plus the rotational clock motion. So we got 4 ways of motion that are seen on the sun and moon. And we just need a lot of data collection over a long period of time. And if we only had our taxpayer money back and could actually use the toys we paid for that we're not allowed to touch, and get to those like highest mountain big telescopes, or the ones allegedly up above the clouds all the time. And that's another issue. If we have telescopes allegedly in space, such as Stereo A, Stereo B, so forth, and SOHO, that are out in space looking at the sun from stationary positions. How do you get stationary positions in the current model, especially if the sun is hurtling through space with everything spiraling behind it and around it? How do you get a stationary motion such that you can pick a fixed point in the sky and watch the sun turn? You can't. It's impossible, even by their own standards. So, you know, even if you've got your telescopes above the clouds, above atmospheric distortion, you still have a problem with a moving camera. And so their sun motions don't mean squat compared to anybody else's sun motions here on the Earth. Looking at the chat, what kind of filter do you use? I went to Amazon and got a polymer film for a sheet, a 4x4 sheet, for about $10. It comes as a flat sheet, very tightly between 2 pieces of cardboard, and what they tell you to do is cut to whatever shape and size you want while it's still in the cardboard, and then carefully peel off the cardboard and put it in whatever holder you want to put it in. So that's what works for me. Let me see if I can go to Amazon quick and find what I ordered, and I'll see if I can get you a link. Orders. Let's see, past 6 months. Hold on, sorry, let me look for that, because it was a while ago. All right. Oh, this is the 8x8. It was $20. Should be able to use this link that I will put in the chat and find that product. But yeah, what I did was I also bought, let's see if I can find that, a bunch of adapter rings for the, you know, not just the P900, but for any camera. They're different millimeter size rings. And yep, there we go. Let me get that link. I'll explain what I did with it in a second. Yep, there's all sorts of ways to do this, but what I did then was I cut, or I had my husband cut because my hands don't work very well, cut a circle out of one corner of the sheet, so I could, and I cut other circles out of different sizes for different my telescope and some binoculars and other things that I used on the day of the eclipse. I had a whole bunch of filters made out of that one sheet. And the one for the P900, what I did was I took those adapter rings. I got one that was, you know, went from 67 millimeter to, I think it was a little bit smaller, whatever the step was. I can't remember the number. And I cut the circle so that it would be just too big to fall out the bottom of that ring, okay? Now I needed a way to keep it from going out the top of that ring. So I put another smaller ring the next step down on top of that. So that piece of polymer film was trapped between the two. And that's what I've been using my filter, and just screws on and off. I taped the two, using electrical tape, I taped the two adapter rings together. Now, I wish I had some very good clear plastic to put on either side so I wouldn't ruin the film, the polymer film, but I just have to be real careful. But it does keep it nice and flat, and it's easy to put on and remove from the lens, the P900 lens, and it works really well. Yeah, any kind of scope. I might be even willing to sell mine, but you would have to understand, A, shipping costs, and B, this is, it has an equatorial mount, a motorized mount, but it doesn't work anymore. You tell it to find an object in the sky and it'll just keep spinning and spinning and spinning. It seems to have lost its mind. It is old. It's a Meade. It's got a 3.5-inch diameter barrel. It has various eyepieces for magnification, but the more you magnify, the smaller that tiny little piece of lens gets, and it's really hard to see after a while. The worst thing about this scope, mounted permanently as it is to the motor part, if you're looking straight up, the focus ring is in parallel with the lens barrel, and if that lens barrel is almost up, then you have almost no room for your fingers to turn that tiny little thumb screw. Focusing is a nightmare. But I'm willing to part with it for those reasons and get something that I can operate with my arthritic fingers. Your mileage may vary, but I am willing to sell it. But I don't know. I mean, I forget what it cost new. It's been a long time. But it's a half decent scope, and it will magnify, but you're just going to have to line things up manually. But anyway, yeah, the thing about a scope, that's why you don't want to put a lot of money into a new one unless you're really super serious and you got a bunch of money to throw at it. I mean, thousands, to get one of those Celestron, high-end things. You can get some phenomenal pictures, but it's going to take hours of night viewing. And the stars, even with this scope, when it was working and I could track stuff and actually get the focus to get where I wanted, I have seen the rings of Saturn. I've seen the stripes of Jupiter. But that's pretty much it. If you focus on a star, you're still going to get a point of light. The P900 does what I want it to do. I can see. I have yet to see the stripes of Jupiter, though, with the P900, because for some reason I can't get the exposure trick to work, which is where you shine a flashlight at the lens to fool the exposure, and then you lock it there, and then you zoom in on Jupiter. And I haven't been able to get it to lock that exposure the way I want it to. So, but yeah, I do have a scope I could part with. I'm not sure how much good it would do you, but like I said, you'd probably pay more in shipping than it would be worth. And the case is broken. But the scope itself works. I did use it for the eclipse. I wanted to put my old camera on it. I have a bracket that holds it on the eyepiece, but I just couldn't get it to work very well that day because of all the clouds and whatnot. And by the time the clouds parted, I was zoned on using the P900 and didn't have time to mess with the other equipment by then. So yeah, I would agree with that suggestion in the chat that you just try to find somebody local who's parting with one, maybe a garage sale even. So I don't know. Anyway, back to the plot thickens, the spot thickens on the sun motion. I think that picture I've had up pretty much says what the issue is. The dilemma with current models is that on a given day, you will see clock motion from one day to the next. If you're tracking the same set of spots, you will see them move roughly in the same direction laterally, but at different speeds, even though they're all close to the equator, which shouldn't be the case. And I'd need a lot. That's the first time I've tracked a lateral motion, and it's hit or miss because here where I live, we get so much clouds that pop up from nowhere, chemtrailing and whatnot, that getting a set of spots to be able to track it over several days is really a miracle. It's very unusual. This time of year, though, tends to be drier and clearer, so I'm hoping to be able to track these. But here again, I'm tracking it near an equinox, and I want to see what the same, what a set of spots would do laterally from one day to the next at the next solstice, which isn't going to happen until next year because I'm not likely to go out at the end, the few days before Christmas and track the sun from one day to the next and hope there's no clouds. Not likely to happen. And there needs to be a lot more of that kind of data collection to verify or debunk the idea that sunspots really move across the face of the sun rather than clock motion. So this is all I've got, and I don't know how we're going to do better without a whole bunch of reliable people who know what they're doing and can be counted on not to fudge anything, and have clear weather and spots to look at over, say, a course of 4 or 5 days, because that's about all we're going to hope for. I don't think spots last much more than that, at least that I've seen. But like I said, a lot of times I just can't watch them for one reason or another. Either I'm, we got bad weather, or I'm away from home or something. And, starting Friday, I'll probably be busy all weekend. I might get some time. If I can just get the early morning ones, that would be fine for this purpose. But anyway, it is frustrating, but at least we have that. And I don't know what else we can hope to do. But there you go. That's my sun tracking for this week. I don't know of anything else I need to talk about, randomly updates or anything other than that. If you watched my goodbye video from a few days ago, I think like 5 days ago, that I'm pretty much not going on other channels. I might watch some, but I'm not going to chat. I'm not going to be on panel. I'm not going to make my presence known anywhere I go, except for if it happens to be something unrelated to anybody I know, like, for example, some astronomy site that nobody knows me at, I might comment there, but very rare that I'm going to be chatting or commenting on videos or being in a live stream chat, or especially being on panels. I'm just not, for the foreseeable future. I don't know if I'll ever change my mind, but like I said in that goodbye video, I will talk privately with people, but I'm not going public to any channels. I have my reasons, and you can watch the video if you want, if you haven't yet. But so today, lately, other videos I've been ranting about the dangers of New Age theology, New Age pseudo-religion, false religion, whatever you want to call it, and that it is the religion of the powers that be. But today I had some sun material, so that's what I'm doing. And I really don't know what I have to add to the sun issue unless I can track it over several days, which is really a gamble of where I live. But I'll see what I can do tomorrow, maybe Friday. We'll see what the conditions are. Other than that, like I said, I'm just going to stay out of things and talk about whatever I feel like talking about, which is either going to be probably science things or Bible things. And just in general about the Bible things, the uncanny need for most people to have some kind of spirituality, which ought to tell them something, first of all. And second of all, that it, just because a person changes their ideas about something doesn't mean they've improved. Whether it's within Bible theology, positions of prophecy or whatnot, or conspiracy theories, you can't say that if you changed your mind that you made an improvement. You've just changed your mind. And so it is with people who are recognizing that there must be a creator after all, aren't necessarily going to find the real creator. They're going to be led in other directions, as I've been saying in videos. And in the end, everybody has faith in their story that they believe. And I believe some faiths have more basis in objectivity than others, but then other people don't believe in objectivity whatsoever unless it suits them, and then they use it. So consistency is a big deal to me. And so anyway, that's pretty much all I have to say today, and I think I'll probably shut down. Yep, people want to, well, even if they are searching, they want to search but not find. That's why when you tell them, look, this is the truth, Jesus is the truth, they go ballistic. They get very angry and accusatory, and as I said in my Goodbye video, some of them will say we're all about peace and love and unity, unless, except for you, as another video title put it, except for you Christians, it's just, in the Bible, if you stand up for your convictions, we're not so loving and unified after all, are we? So anyway, enough about that, enough about them. And I'm watching the sun because I can. And it's not like I'm not doing anything else. I have done my share of things that I think are more important, which is the spiritual aspect. But there's no reason why we can't do both. And how I spend my time is nobody else's business. So, because I'm just referring in general to other Christians who critique me for doing anything but Bible all the time. And of course, they don't do anything but Bible all the time. They spend most of their time backstabbing other Christians, which, as like I said, it goes way back before internet even. And then it was, blogs, then message boards, now YouTube, where Christians spend too much time critiquing each other and not enough time unifying around the gospel. And instead they want to tell you that because of your flesh you can't do this or that, you're not allowed, or because of your view on prophecy, if you think Jesus comes 3.5 years earlier than I do, then you're got a demon spirit or something like that. I'm just tired of that. I've had it. So anyway, enough about all that. Yes, other religions, as for the chat, they do want you to work for your salvation, every single one of them. And even some people within Christianity believe that you have to at least partially work for it. But salvation is either a gift or it's not. It's either a gift or a wage, and the Bible does contrast the two. And so it can't be both, no matter how you look at it. And so any religion, and even any Christian so-called theology that tells you to work for your salvation doesn't understand salvation. It's a gift that only Jesus earned, and only Jesus can give. And so anything that says endure to the end and you will be saved is not talking to Christians. Pure and simple. I mean, So anyway, I think I will shut down because I got nothing else to say right now. So I'll talk to you all later. Thanks for coming.